Hi everybody. All right, let's do the 10-4 notes. Okay, we're gonna skip the explore and reason and go right into example 1 and explain what an inscribed angle is. So an inscribed angle has its vertex on the circle's edge and its sides contain chords of a circle. So this here is called the inscribed angle. Angle C is the inscribed angle in this circle. Notice the vertex is on the circle's edge, and then the sides are the chords inside the circle. All right, so let's take a look at this and explore it. So we have triangle QCB is an isosceles. So that means this angle is equal to this angle, and it's isosceles because these are both radii of the circle. Okay, this is a radius and this is a radius, so this would have to be congruent angles. So let's see how that will help us figure out what the relationship between this angle measure is and this angle measure is. Okay, so we draw a radius QB here to form the triangle, which is an isosceles. Okay. Central angle AQB, we'll call that X. So central angle, so angle A, let angle AQB be X, represented by X like the picture is showing. Okay, if we apply the exterior angle theorem, if you remember that, so apply the triangle exterior angle theorem. It tells us, if you remember, we did this way back when, it says the exterior angle is equal to the sum of the measure of the remote interior angles. Okay, so in this case, measurement X is equal to, this exterior angle is equal to measurement of angle QBC, which I have here in green, plus measurement of angle QCB, which is also green. Okay, let's put the dots here, they're isosceles. Okay, so these two angles are congruent. Because they are congruent, I can replace this one with QCB or this one with QBC because they're the same. So by substitution, I know measurement of angle QBC is equal to measurement of angle QCB. So by substitution, I can rewrite this, okay, as X is equal to measurement of angle QCB plus measurement of angle QCB. So now I have two of them. So I'm just going to do the algebra here and simplify it. X equals 2 times the measure of angle QCB. Okay, so then to get the measurement of QCB, which is my central angle that I'm looking at here, okay, divide by 2. Divide by 2. So then we get half of X is equal to measurement of angle QCB. So that's our conclusion here, is the measure of the central angle is half the measure of the, the measure of the inscribed angle. The measure of the inscribed angle, this is the inscribed angle, QCB, is half of the measure of the central angle, which is X. This is the central angle. Okay, X is the central angle. Okay, this is the inscribed angle. Okay, so the measure of the inscribed angle, ACB, they named it ACB here, it's the same one that we're talking about, is half the measure of the intercepted arc, AB. And that's how they phrase it, because guess what? If you remember, the intercepted arc is equal to the central angle. Remember, the measurement of angle x is the same as the intercepted arc. So then I can relate this angle to this arc. So the measure of the inscribed angle is half the measure of the intercepted arc. Okay? Okay, so here it is. So study tip here, there are infinitely many inscribed angles that intercept the arc. These inscribed angles all have the same angle measure. Okay, so what we are saying here, I'll show you. So draw four more inscribed angles that intercept the same arc in the diagram. So let's say I want to make an intercepted or inscribed angle here. Okay, I'll make one here, inscribed angle. Let's make one here. See, that's the same intercepted arc. Okay, let's finish the inscribed angle here that I started. Okay, and here's another one. I can draw infinitely many inscribed angles that intercept the same arc. All of these angles, the orange one, the blue one, and the green one, they're all inscribed and they intercept the same arc. So they all measure the same thing. And this one, they all have the same measurements. For a given circle P with an inscribed angle S, if measurement of arc RT is 47 degrees, what is measurement of angle S? Well, angle S is the inscribed angle and it's half the intercepted arc. So measurement of angle S is half the measurement of the intercepted arc. So therefore it is half of 47, which is 23.5 degrees. Okay? See if you can pause the video and answer these, and then you can come back and check. Okay, find the indicated measure in circle P, measurement of angle T. It's half of 48. So measurement of angle T is 24 degrees. Measurement of arc ST. Arc ST. Well, arc ST. Okay, so arc TR here, that's a semicircle. TR is a diameter. Okay, so arc TR is a semicircle. So that means it measures 180 degrees. So if TR is 180, this is 48, then TS, arc TS, would be 180 minus 48 degrees, which is 132 degrees. Okay? Measurement of arc QT. QT. Well, the inscribed angle is half of the intercepted arc. So then I know the inscribed angle, so the arc would be twice that. So that's 100 degrees. Okay, measurement of arc QR. Well, like I did with measurement of arc ST. Okay, TR here is a semicircle. Okay, so TR, arc TR is a semicircle. Okay, so it equals 180 degrees. Okay, and QT is 100, like we found previously. So then QR is going to be 180 minus 100, which is 80 degrees. Okay. And then extra practice. Find measurement of arc SR and measurement of angle STR. STR. So we're finding the measurement of this angle and the measurement of SR, the arc. Okay, measurement of arc SR is going to be double the inscribed angle. Okay, so it's going to be twice of 31, which is 62 degrees. Okay, measurement of angle STR is going to be half of the 62, or it's going to be the same as that U. You can look at it that way too, because they intercept the same arc. Okay, so measurement of angle STR is half of 62, which is 31. And they are equal. They intercept the same arc. Measurement of angle STR is the same as measurement of angle SUR. Okay. So here is the inscribed angles theorem. And you'll see inscribed angles in three different ways, three different cases. Okay, the center is on one side of the angle. So this is the angle. Okay, and one side of the angle includes the center of the circle, is what they're saying. Okay, if that's the case, then the measurement of angle S is still half the intercepted arc. Okay, case 2 is you will see the angle, the center is in the inside of the angle. Well, it's fine, it's still the same rule. Okay, in the third case, you will see the center is outside of the angle. It's still the same rule. So, the measurement of the inscribed angle, angle S in this case, in all these pictures, is always half of the intercepted arc. Half the measure of the intercepted arc, always, in all cases. All right, so let's apply that here. Again, pause the video and then see if you can do those, then come back and check. All right, measurement of angle HGF. So this angle, well, that's half the intercepted arc. It's half of 90, so it's 45 degrees. Okay, measurement of arc TV. Well, the inscribed angle is half of the arc. So that's going to be twice 38, which is 76 degrees. All right, let's do more practice problems, or go ahead and feel free to do the, more practice problems here. And then come back and check your answer. All right, if measurement of arc DG is 45.5, so this is 45.5, what are measurement of angle E and F? Okay, E and F are congruent because they intercept the same arc. So they are equal, and they're going to be double, or excuse me, they're going to be half of the intercepted arc. So it's half of the 45.6, which is 22.8 degrees. Okay, if arc RT is a semicircle, that means it's 180 degrees. What is the measurement of angle RST? Well, that's the inscribed angle, and that's the intercepted arc. So the inscribed angle is half of 180. So measurement of angle RST is half of 180, which is 90 degrees. All right, we are going to skip C. It's doable, but it's just time consuming, so you can try it if you would like, but I'm going to skip it. Okay, moving on to this one. If measurement of arc RST is 164, so this is 164, that's a major arc. What is measurement of angle RVT? RVT, so that's the inscribed angle that's intercepted by the arc. It's going to be half of 164, and that is 82 degrees. Okay, and then if measurement of angle SPU is 79, so this is 79 degrees, that's the inscribed angle. What is measurement of S arc STU? That's the intercepted arc. So that's going to be double the 79. 158 degrees. Okay. All of these notes, they are filled out and they're posted on the calendar. So if you need to see the filled out notes, you can certainly go ahead and look at it on the calendar. All right, we have a couple of corollaries to the inscribed angle theorem. If two inscribed angles that intercept the same arc are congruent, okay, then the angles are congruent. Okay, so what we're saying here is two inscribed angles, which is what we just did, by the way, in this problem. So they're saying if they intercept the same arc, then they are congruent. Okay, so angle S and angle T in this case, angle S and angle T, they intercept this same arc, okay, which is arc RU. So to that, we can also look at angle R and angle U. Those are going to be congruent because they are intercepted, or they intercept arc ST. So those are congruent. Okay, and then the corollary number 2, an angle inscribed in a semicircle is a right angle. So this angle is inscribed in a semicircle. See the arc ST here is the intercepted arc, and arc ST is the semicircle. So then this would have to be a 90-degree angle. So this is 90 degrees. Okay? Corollary number 3. The opposite angles of an inscribed quadrilateral are supplementary. All right. So this one, is saying if we have four different inscribed angles, they form a quadrilateral that is inside of the circle. Okay? So opposite angles are supplementary is what this corollary says. So in other words, R plus T add up to 180, and then U plus S, these are opposite angles, they are supplementary, they add up to 180. Okay? And then there is one more explore theorem that one more theorem in this section that we're going to do quickly. Okay, so for this given chord FH and line HG, which is tangent to the circle, what is the relationship between angle FHJ, so what's the relationship between this angle, FHJ, and arc FGH? Okay, so here in this example we have a tangent and we have a chord. And we need to figure out the relationship between this angle and this chord. Okay, so this is a derivation of what I'm going to show you, the rule that I'm going to give you. Okay, if you want to see that work out, I have it in my notes, in my posted notes. Okay, so I can go over it quickly here, but I can, it's still, the good news is that it's the same. Okay, the measurement of the angle, the measurement of this angle is half that arc that is made by the chord of that angle. So the angle is a tangent line and a chord. It's still half of that arc. Okay, and that's why it works. So you can pause the video, look at my explanation thoroughly. Okay, this is nothing you need to recreate on the test or anything, but it shows you why it is derived that the angle is half of that arc. Okay? So let's look at these examples. Given BD is a tangent to circle P at point C. If measurement of arc AC is 88, what is measurement of angle ACB? By the way, angle ACB is this one. Okay, like from here, it's this one, this angle. Okay, so it's half. Measurement of angle ACB is half of the arc, half of 88, which is 44 degrees. Okay? So if measurement of AC, that one, okay, so then here's the same picture. Given EG, so now we're looking at this tangent. Okay, this is tangent to point F. If measurement of angle G FC is 115, GFC. So that's from here to here, that's 115. It includes this part. Okay, GFC, it includes this part. It's from here to here. Okay, if that's 115, what is measurement of arc FAC? So this arc from here to here. It's going to be twice of that. So it's 230 degrees. Okay? And remember, if I have a tangent line and a diameter, the tangent is perpendicular to the diameter. And that's how I start this problem here. This is perpendicular. And that's how I begin this, if you can call it proof if you want to. Okay? Do a couple problems with the supplementary angles theorem. So find the value or the corollary of the supplementary opposite angles are supplementary here. So find the value of each variable from the corollary we just did. These two are supplementary, so they add up to 180. And these two are supplementary, so they add up to 180. So x is 100 and y is 105. Okay, x would have to be 100 and y is 180 minus 75, which is 105. And then likewise here. So we got 2a plus 2a is 180. Those are opposite angles. Okay, so a equals 45. And then we have 4b plus 2b add up to 180. So 6b equals 180. So b is 30. All right, here's the formal theorem 10.9. The measure of an angle formed by a tangent and a chord, so a tangent and a chord, is half the measure of its intercepted arc. So if we have a tangent and a chord, then measurement of angle AED, this one, is half of the arc, intercepted arc. So that's half of this arc. All right, so with that, we can finish these problems. So line M is tangent to the circle, and here's the chord. Find the measurement of the angle or the arc. So here I want to find the measurement of angle 1. It's half of 150. So it's 75 degrees. Okay, and then here we want to find the measurement of this arc. Okay, well, it's twice of this angle, so twice of 130, which is 260 degrees. All right, I'm going to pause the video here. You should be able to do the homework for this lesson. Here, there's more practice problems here that are, there's a word problem and more practice problems, but you should be able to do the homework at this point. All right, enjoy the day.